You know what Silicon Valley's ultra-rich people are betting on? Like Amazon founder Jeff Bezos and OpenAI CEO Sam Altman, each has sunk billions of dollars, all into one single field: anti-aging technology. The body is business's most productive machine, and aging is the most inevitable and most terrifying depreciation it'll ever face. How far can anti-aging tech really go? Picture this. When you're 80, you still have the stamina, memory, and productivity of a 30-year-old. Wouldn't that be a dream that comes true? So how far has this anti-aging revolution, fueled by global capital, actually come? I'm Dr. Zhang Dingjing from Geriatrics. Before we dive in, check if you've hit subscribe. We're gunning for 100,000 subs by June. Just missing you. Now let's use science as the key to unlock a long, healthy life. We've spent a lot of time showing you how to fight cancer, heart disease, diabetes, and all sorts of chronic illnesses. But have you ever thought what the one risk factor they all have in common is? The answer's simple. Getting old. Live long enough, your cells start glitching, and disease shows up. As we've covered before, aging is a whole-body event. Cells signal each other through exosomes, gradually syncing up the biological age of every organ. If you're curious about that, click here to catch up. Doctors long thought irreversible DNA mutations caused aging. Like an old car, once the parts wear out, it's beyond saving. But in recent years, Harvard's leading longevity researcher, Professor David Sinclair, dropped a theory that rocked the field. He argued that our DNA isn't actually damaged. What's broken is the system that reads it. In our field, we call this specific phenomenon epigenetic noise. Let me break this down with a simple analogy. Every cell in your body, whether it's heart, liver, or skin, carries the exact same DNA blueprint. So why can the heart beat while skin sprouts hair? Here's the key. On top of the DNA sits a set of epigenetic modifications. It's like sticky notes plastered all over a thick gene manual. They tell your heart cells to read only the heart chapter. Every other chapter, sealed shut. But as you age, as stress piles on, and especially as DNA keeps snapping and mending day after day, those epigenetic bookmarks drift to the wrong spot or just fall off and get lost. The result? The DNA info is all still there, but the cell's reading machinery can no longer find the right page. So the cell starts to glitch out and stall. In your body, it means your heart cells forget how to pump efficiently, and your skin cells forget how to churn out collagen. In our field, we call this phenomenon mesenchymal drift. Mesenchymal drift means that cells have lost their original identity. Now, science has more than one theory on aging. We've talked about telomere shortening, mitochondrial dysfunction, and loss of proteostasis. All of these are well-supported aging mechanisms. But in this episode, we're zeroing in on the very logic behind Sinclair's epigenetic theory. If the root of aging is bookmarks stuck in the wrong place, could we just wipe it clean, reinstall it from scratch, and reboot the cell? In 2006, Japanese scientist Shinya Yamanaka discovered 4 transcription factors, OSKM. We call them the Yamanaka Factors. These 4 factors can force a mature cell all the way back to a blank slate state. Nothing decided yet. Think of it this way. You're playing a role-playing game. You've already picked a class and leveled up into a powerful warrior or mage. At that point, your cells are locked in. But the Yamanaka factors are basically a class reset scroll or a rebirth potion if you use it. On a max-level character, with one click, they snap back to level 0, where you didn't even pick a class. In that state, they're no longer just a warrior whose role is simply to slay monsters. They've regained limitless potential. You can be a healer, an archer, or any class again. At the time, this completely shattered the dogma that biology is a one-way street and earned Professor Yamanaka the Nobel Prize in 2012. But when scientists eagerly tested it on mice, problems hit right away. It was too powerful. The cells didn't just get younger. Their identity got wiped along with it. So you'd see, heart muscle cells forget how to beat. The heart just quits. What's worse, one of the 4 factors, c-MYC, is itself an oncogene. So once these identity-wiped cells spiral out, they may sprout into tumors packed with hair, teeth, and bones. So that leaves us with a brutal dilemma. Either you slowly die of old age, or you turn young again, but die of cancer. That's why this tech stalled for nearly 20 years and never made it out of the lab. But scientists never stop. They keep pushing. They thought, what if we skip the full reformat and just gently erase the marks of time? That's exactly what we call partial reprogramming. Simply put, genetic whiteout. The idea is to strip out the cancer-causing M factor, keep only the safer O, S, and K, and then tightly control how long they run. A light touch, then stop. Great in theory, brutal in practice. Your body has trillions of cells. If you inject this whiteout into the body, how do you control it precisely? What if it goes haywire inside you? Then what? To crack the delivery and control problem, the world's top biotech players have split into 3 camps, each engineering its own kill switch. We call Camp 1, the ultra-safe manual mode. The leader of this camp is Professor David Sinclair's very own company, Life Biosciences. Their approach is to package the gene tool inside a harmless virus and deliver it into the body. But by default, it stays completely off. To flip it on, you swallow a specific trigger pill, which is actually just a common antibiotic, doxycycline. But once you stop taking it, everything shuts down. You can pull the plug anytime. Because this shutdown mechanism is so safe, in Q1 of 2026, for the first time in medical history, a human clinical trial in cellular reprogramming launched. Life Biosciences secured FDA clearance for human testing in eye diseases. They picked the eye, specifically treating glaucoma or optic neuropathy, because the eye is like a sealed-off room. If something goes wrong, it stays in the eyeball and won't spread through the body. And if all goes well, within a year or 2, we could see a major breakthrough in vision restoration. Camp 2's more sci-fi, fully automated upkeep. You must be familiar with the leaders, the super unicorn Altos Labs, supported by Amazon founder Bezos and many other investors. They assembled an ever-fantastic scientific team. Even Nobel laureate Yamanaka himself is currently serving as their senior science advisor. They think, wait, still need pills? Too much hassle. Why not just wire an automatic patrol system right into the gene tool? That's how the CDKN2A sensor was born. This thing sits on standby 24/7. The moment it spots senescent zombie cells in your body, which no longer divide, won't die, and just keep spewing inflammatory toxins. Very stubborn cells. It kicks on automatically. Precisely sprays OSK whiteout to erase age marks. Once the repair is done, it shuts itself off, completely hands-free. Then in 2024, Science Translational Medicine published a study showing that in progerium mice, this approach genuinely extended lifespan. But don't celebrate just yet. There's a saying in medicine, what works in mice ends up failing in humans about 90% of the time. And we all know the FDA gauntlet is brutal. So to make sure this system won't suddenly go rogue and turn cancerous years later, we'll likely need a few more years to prove safety in other primates first, before using it in humans. The last camp is a longevity startup heavily backed by OpenAI CEO Retro Biosciences. This most hardcore science-heavy camp. It takes Silicon Valley's favorite AI brute force route. Their logic is that if the repair factors in nature aren't good enough, why not use cutting-edge generative AI to redesign protein structures and engineer the ultimate repair factor ourselves? In 2025, they successfully built an AI-optimized repair factor that clocked in at a full 50 times more potent than conventional ones. But this path is also the riskiest. This is a foreign substance the human body has never encountered, so it is possible that it triggers an immune storm and the body attacks itself. That's why the FDA will demand extremely rigorous immune rejection and toxicity testing. This technology is still at a very early lab stage. We're looking at least 3 to 5 more years before it can even get near clinical trials. But before we get swept up in these rosy visions, as a doctor, I need to tap the brakes. You know the blind man and the elephant. The aging we're discussing today is that elephant. Scientists are feeling aging from many different angles, and they've uncovered real clues. But we have to acknowledge that right now, nobody can say for certain whether what we covered today captures the whole elephant or just one leg. So here's my reminder. In this war against aging, there may be more than one enemy, and no single silver bullet will end it. Before that final answer arrives, keep following our show. Let me help you find the healthiest path that works for you. Want the latest medical breakthroughs? Subscribe, become a member, and join Team Health. Let's stay healthy together.